Hello, I'm Emma-Louise Coffey and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. With the return of investment of €6 for every €1 spent on lime to improve soil pH, the question remains why more farmers don't spread lime to keep soil at optimum pH levels. And on this week's episode of the Dairy Edge, Ger Courtney joins us to explain how and why a liming programme is so important. And I first asked him where soil pH levels are nationally.
I suppose when we're talking about pH, we're talking about a range of 1 to 14, and the optimum is where we get the maximum availability of nutrients, which is 6.3 for mineral soils and 5.5 to 5.8 for our peat soils, which would be a small enough proportion nationally. So I suppose in terms of the soil samples that have been done in recent years, we are seeing a gradual improvement, but coming from a pretty low base. I was looking at the data there from Mark Plunkett to 2014 to 2016. At that stage, 37% of samples were optimum for pH. And in the more recent period, in 2017, 2018, that had improved to 54%. So about half our samples that were tested in that 2-year time frame were correct, we'll say, our optimum for pH. Now the story is a little bit better in the dairy situation, where 36% of our samples back in 14-16 were effectively optimum. That has gone up now to about 60% of our soils in the dairy scenario, nationally being correct for pH. But it still means that we have 40% of our samples deficient in lime, and that's closer probably to 50% or half again in the high rainfall areas.
And if we consider the results that you're quoting, Ger, what percentage of national grasslands would the soil samples represent?
Yeah, well, in each year you're doing about 45,000 soil samples. So across each of those 2-year periods, you're talking about a fairly strong database of about 90,000 soil samples, probably representing 4 to 5 hectares per sample. So you're talking about more than 1 million hectares, effectively across a 5-year time span being represented in each of those 2-year periods. So, national grassland area is about 3.5 million hectares. So, you're talking about a third of the area being represented by soil samples, which is probably the most agriculturally productive area as well. So I'd be pretty happy that it's a pretty good, I suppose, overall picture of where we are with soil pH.
And you mentioned a target pH of 6.3 and, a slightly lower pH on peaty soils. What does this actually mean?
Well, I suppose effectively, if you talk about pH, you're talking about, it's probably the single most important chemical property of soil, and it's really a measure of the acidity of the soil. So when we're looking at the pH that comes back from the lab in the soil test results, it'll generally be in the range 5 to maybe 7.5. They're the typical results coming back. But I suppose all the evidence and all the research down through the years has focused really in terms of the optimum availability of nutrients at low levels of acidity. So if you take a pH of 7 as being neutral, so no acidity, and then you take a range, say 6.3 to 7, where you have very low levels of acidity. Also within that range of 6.3 to 7, you have actually the maximum or optimum availability of nutrients to the plants. So for that reason, the target is set very strictly around that 6.3, maybe to lime, to, for example, 6.5 to achieve at least a 6.3 optimum, and then not exceeding 7 because you're tending to become over-alkaline. And I suppose the big issue in terms of pH is that it is a measure of acidity in soils. So if you take a neutral soil of pH of 7, there's no acid, no acidity. But it is a logarithmic scale. So effectively, what that means is that by the time you drop the pH from 7 to 6, you actually have 10 times more acidity. So there's a factor of 10. But if you drop the pH further to 5, there's actually 100 times more acidity. There's a factor of 100 in terms of the difference between the acidity at 5 and compared to 7. So obviously that huge amount of acidity as we drop pH lower than say 6.5, 6.3, as that pH is falling, the whole build-up of acidity in the soil, it's very detrimental for microorganisms, for biological life, for earthworm activity. These are all crucial for proper root structure, for soil structure, and in order to, I suppose, maximize our grass growth, which is effectively, or any of our crops in the tillage scenario, we do find that the highest availability and of nutrients and the acid level that those plants can tolerate best is in the range of 6.3 to 7 for a mineral type soil.
And you know, where you're depleting your pH on farm, like, you know, you're pointing to the you know, you're coming away from your optimum availability of your, you know, your other nutrients in the soil. You know, things that we talk about a lot would be P and K, but you're also looking at the biology of the soil. And I suppose, you know, what's going on underneath the ground and in the soil has a huge impact on our ability to grow grass. Could you quantify, say, the limitation in grass production where a soil has reduced to, say, a pH of 5.5 compared with the optimum of 6.3?
Yeah, so you have a combination of things working. Then you have high acid load at pH of 5, and you have poor biological activity, poor microorganism activity, and then you have fixation by iron and aluminium, fixation of phosphate in particular, of iron and aluminium, which is basically reducing the availability of phosphate to the plant. So the impact of all those together is quite significant to our ryegrass and our sward, our various plant crops. It would be in the order in research of 1.5 tons per hectare per annum in terms of grass growth. We found in the heavy soils farms that actually have higher levels of clay soils and therefore higher levels of iron and aluminium, that there was actually more fixation at those lower pHs. And when they did shift the pH up towards the 6.2, 6.3, they actually got benefits to the order of 2 tons per hectare in grass growth across the season. And that's a cumulative type of figure. It doesn't all happen together. You get an impact year 1, but as year 2 and as the whole microflora in the soil improves and the biology of the soil improves and the soil pH stabilizes at the 6.3, it's then you get the full benefit in terms of a soil that's really working optimally for grass growth. So certainly, I mean, when you talk about 2 tons per hectare, if you were to equate that to, for example, we were very short of silage 2 or 3 years ago, it's the equivalent of 10 bales per hectare or 4 bales per acre, so our standard round bale. So that's a significant loss of production on a hectare that has a low pH of 5.5.
And, you know, I suppose the solution to a lower pH is lime, and that's the common product we're using on farms to lift our levels of pH. Can you talk us through the trend of lime usage on farms across Ireland?
Okay, Emma-Louise, well, I mean, it's a cheap product, it's widely available, and it's amazing that it's not being used more widely as part of our fertilizer program, because it is such a basic requirement to correct pH. In an acid soil, we add an alkaline product like calcium in the form of ground limestone. It's a very simple solution to a low pH issue, and as one of our monitor farms called it last week, a quick fix solution. So in terms of soil fertility, in terms of correcting an issue. So I was looking at data there in terms of what kind of lime quantities have we been using nationally, and back in 2008, for example, it was 600,000 tons per annum. And that has improved now to 1 million tons per annum in 2018. So a significant improvement, but still a long ways to go in terms of the national requirement. And if you look across that period, 2008 up to 2013, it averaged about 800,000 tons of lime, which would actually only be about half the requirement to maintain the national pH. So obviously we have losses and we need a maintenance requirement of lime each year to overcome or deal with those losses of lime from the soil. So really 800,000 back in those years was really only scratching at the surface in terms of the amount of lime required nationally for optimum production. It has improved now in the more recent 4 or 5 year period. It's averaged at 900,000. So that's a 10 to 12% increase. And certainly last year was one of our better years. Like over the million, we broke the million barrier, but we need to push on nationally towards that 1.5, 1.7 million tons of lime spread nationally, as I say, even to meet the basic requirement of maintenance of our grassland soils in particular.
So you're quantifying it at, say, 1.5 to 1.7 million tons for maintenance. If we were to add build up to that for lower soils, are you looking at a higher figure again?
Yeah, absolutely. So look, I mean, the maintenance is where you're at 6.3, and we can talk about that. But effectively, you're pushing on over the 2 million tons. If you were to properly correct all the grassland soils of the country in terms of pH, and then meet the maintenance requirement, which is quite high in high rainfall areas. And we obviously have a very acidic bedrock across most of our country, so our soils are naturally acidic, so there is a maintenance requirement coming in on an annual basis for lime.
And you know, you talk about maintenance, and we'll delve into that a little bit, Ger. You know, we can quantify the amount of P and K offtake. You know, we talk, if you're producing milk or meat on farms, you know, there's, you know, per 1,000 litres of milk, we know how much P we're going to lose. And, you know, when we look at K, you know, we have a very high offtake of K when we're cutting silage. Could you quantify, say, you know, what an annual offtake of lime would be on a typical dairy farm?
Yeah, Emma-Louise, I suppose the offtake is slightly different when we come to lime, because obviously it's a natural product and it's added to the soil, but then the key losses are through rainfall and drainage, which would make up about half the losses, and I'll quantify them maybe in a second. And the second one is increased use of nitrogen fertilizers and organic manures. So they're the two big elements in terms of offtake of lime from a grassland paddock, for example. The offtake actually from livestock or from milk is quite low. For example, 1,000 litres of milk only removes 3 kilos of lime. Or a bullock only removes 25 kilos of lime. So that whole, we'll call it, you mentioned there, the phosphate and the potash, which is quite a lot of it removed in terms of the product. But in the case of lime, it's drainage, and particularly in the high rainfall areas. So we did some data on that there with David Wall over the last number of years. And if you looked, for example, at a scenario where you were using 250 kilos of nitrogen per hectare, that's really removing about 500 kilos per annum. Maybe 15,000 litres of milk per hectare, 45 kilos. Then the loss in drainage average across the country, maybe 455 kilos. You're effectively coming to a tonne being lost from each hectare each year. So in simple parlance, that's 2 tonnes per acre every 5 years is actually the drainage or the loss through the main arteries of drainage and nitrogen fertilizer. And whereas maybe in other areas you have higher rainfall but maybe lower nitrogen inputs, it still balances out close enough to about the tonne lost from each hectare each year.
And
so it's quite significant.
And then if we take it a step further, Ger, like if somebody isn't actively engaging in soil testing on a regular basis, you know, that's something that will give them a good indication of where they're at in terms of their pH status. How often do you recommend farmers soil test?
Well, if we're in a situation where we have no information in terms of our soil pH, obviously you need to soil sample the whole farm immediately and get a baseline situation of where you are. Now, obviously, a lime program one of the issues in the past was maybe overliming initially. So there's clear guidelines in terms of not exceeding more than 7.5 tons per hectare in each application or in any given application. So if you have to put out more lime than that, you actually need to split it across maybe put out the balance in 2 years' time. So I think when you embark on a liming program and your target is to get all your paddocks and all your fields up to scratch within, I would say, a 4 to 5 year period, you need to be sampling about once every 2 years as a minimum to kind of, I suppose, review progress, see how you're going. You obviously will, through your nutrient management plan, get your color-coded maps. They're a great tool to actually focus you throughout the year in terms of the paddocks that need lime. So when you get maybe to year 4 and year 5 and you see that 80% plus of your paddocks have achieved the target pH, well then it's really a maintenance issue after that. And if you're putting out an annual maintenance dressing just to correct those number of paddocks that are slipping back a little, well then you probably don't have to sample quite as often, maybe once every 4 years. So initially I would say once every 2 years in order to review progress. And certainly, as I mentioned earlier, it is a quick fix from the point of view of soil fertility. It's always great to get the soil test results back and you see the improvement. But as well as that, you're going to be seeing the improvement at farm level in terms of the palatability of grass, the graze outs being better, the actual yield of grass, particularly in the shoulders because of the release of extra nutrients, particularly phosphate. All these things start coming together over a year or two, and we've seen it in monitor farms that maybe after 3 to 4 years, the farm has just turned around in terms of its grass production and in terms of graze outs and palatability. So I suppose the key thing is to monitor and measure and monitor, and that's effectively what you're doing with soil analysis.
And in terms of taking action on the soil analysis, you've mentioned that the maximum rate, that's recommended to spread is 7.5 tonnes per hectare, and that would translate to 3 tonnes per acre, if we're using that currency. Talk to us about products. You've mentioned ground limestone. So what's available product-wise to farmers?
Well, I suppose ground limestone is the mainstay. Like, it's calcium carbonate. It's widely available, and it's the, I suppose, most cost-effective way of solution in terms of correcting a low soil pH problem in particular. So you mentioned bringing a 5.5 up to 6. It's going to probably take maybe 2 applications of lime 2 years apart to bring it to the optimum then of 6.3. So that product is the most widely available. It's retailing at about 20 to 25 euros per ton on average, depending on various parts of the country. In some areas you have particularly low magnesium in soils, and you can use a dolomitic type limestone product. It's not as readily available. There's only specific quarries that would actually have it available. So it's one that you might put out in 1 or 2 applications, maybe retest again after 2 years, see how your magnesium levels are, and you can revert to ordinary ground limestone calcium carbonate. So the other products, I suppose, that are on the market would be the granulated lime type products. And again, I suppose the difference between ordinary ground limestone, which has a high neutralizing value, but the key thing about ground limestone is that you have about 35% of ground limestone which is readily available. So straight away it's highly reactive. 350 kilos of the ton starts working straight away, and the rest then of that ton of ground limestone works over a period of maybe 2 years in terms of slow release, gradual improvement in the soil calcium levels. Whereas with the granulime product, you're getting 100% reactive immediately. And obviously that will have an immediate impact in lifting pH, but the difficult is that you will probably have a fall off then, because you don't have that slow release that goes on after years 2 and 3. So you must stick with a maintenance value each year when you're using something like granulime. But from the economic point of view, I saw some data there from David Corbett recently showing a 5 times more expensive difference between ground limestone to correct pH, and grand lime to do the same work. So grand lime is effectively good where you get to a maintenance point and you have to put small quantities on that will maybe deal with an issue for a short period of time. So it's really a maintenance type product, whereas the ground limestone is really your only cost-effective type of option in terms of correcting a large-scale low pH issue, and generally it's one that farmers can build into their fertilizer program if it's properly planned out.
And just back to the cost of the ground limestone, that's 20 to 25 euro a tonne spread, is it, Ger?
Yes.
Yeah.
Generally at about 25 euro spread, yeah.
And Ger, there can be some confusion around, say, timing of lime spreading. You see a lot of people would be spreading lime, I suppose, going into this time of year, in the next, I suppose, month to 6 weeks. But it is confusing, you're spreading your lime and what's the effect in terms of when you can spread chemical N and slurry. So if we look at chemical N first, can you give us the rulings on when to spread your lime around that?
Yes, I guess these would be kind of key barriers now to why people don't feel comfortable putting out lime at particular times of the year. So dealing with the urea, for example, there is obviously a reaction with fresh lime. So if you put out fresh lime and then you put out urea immediately afterwards, there is a reaction in terms of the loss of some nitrogen into the atmosphere, and that's not a very desirable economic or environmental, I suppose, thing to happen. So the key message there, and it's the same message for the nitrogen and slurry, is that you put out the slurry or the urea first, and then within 10 days you can apply the lime. So slurry or urea first, and then maybe 10 days later apply your lime. Now this time of the year, obviously, if you apply lime, you have at least a 3-month window before you're applying urea or slurry. So obviously that's quite an adequate gap in terms of the risk of the loss of any nitrogen to the atmosphere is gone by the time January, February comes again. So effectively putting out lime now, it's obviously a very good time from that point of view that you have a 3-month period before any slurry or lime goes out. But in the normal course of the season, you would always go with the slurry or the urea first if that was your option. Now, I've been looking at the pattern of spreading of lime in 2018, and there was about a quarter of the lime nationally spread by the end of June, and then there was still a third of the lime to go out or went out after the 1st of October. So obviously that's an issue some years in terms of weather conditions. Like we've seen a lot of rain now recently, particularly in the region I'm working in down here, 6 or 7 inches of rain in the past month. So obviously ground conditions are not very conducive to spreading lime at the moment. And we're finding more and more that farmers are looking in this part of the world at opportunities throughout the grazing season. So they might look, for example, in the month of April, when grass covers are generally quite low, that maybe there's an area of ground that they can put out a load of lime, which would be about 4 hectares at 2 tons per acre. It might be generally ground that was just grazed or has a cover of less than 700, and once that lime is washed off the leaf, it's quite safe to use in the next round of grazing. There's also opportunities moving into the summer period after taking off baled silage, for example. You have a bare ground where you have very little risk of leaf contamination. That's another great opportunity. Or after the second cut of silage is another opportunity to probably get lime out, because again you have a bare ground, and you have to you have to watch these opportunities where you either have low covers of grass or bare ground. But I think if you have a clear plan in your mind that you need to, for example, get 80 tons of lime out in 2020, you set out different times of the year when potentially you could do that. So maybe April might be an option to get 1 load out. Maybe there's a midsummer option, and there'll obviously be some maybe going out in terms of the reseeding program on the farm, but we try, particularly in the southwest, to try to minimise the amount that we should be putting out in the autumn, because it can be very, very variable in terms of weather conditions. But nationally, it's still about a third of our lime is going out now after the 1st of October. And obviously, it's a good time from the point of view at paddock closing. You get a long run in, you get a winter wash in for the lime, which is ideal. And then you can use your urea and your slurry products without any loss of nitrogen in the springtime.
And I suppose finally to conclude, Ger, you've quantified, I suppose, additional grass growth in the region of 1.5 tons to 2 tons more grass, where we can get to optimum soil pH. And you also mentioned some grazing factors, such as the palatability of the grass that is grown on farms, and I suppose the graze out ability in terms of hitting residuals. Is there a financial figure where we're achieving optimum pH?
Yeah, well, when you look at farms now that have gone through the program, and you get an immediate impact, I would say, in the first 1 to 3 years of your liming program. And you obviously have a capital cost of lime built into that, so the return is probably, I think it has been calculated, close enough to about €3 for every euro you spent in the first 3 years. But then as the pH builds in the farm, you're really moving in towards maintenance. So for the next number of years, your total capital cost in lime is reducing, and maybe across a 5 to 6 year period, when you look at the money you've spent in lime across that 5 year period, you'll actually see, in terms of a growth response, of about 1.5 tons in each hectare. And increased use of nutrients, particularly the fertilizer nutrients you're using. For example, if you're using a product like 18612, at low pH, you're probably only getting half the value from that bag of 18612, whereas at 6.3 to 6.5, you're at optimum efficiency of the nitrogen, the phosphate, and the potash in that bag of 18612. So, in effect, across a 5 to 6 year period, you're really looking at a response of €6 for every euro you've spent on lime. So, I mean, we did the figures in the Kerry program there for the heavy soils farms. For a €400 spend, the benefits coming back were 2,577 is the figure we calculated, and we spoke to the farmers about this, and they were very, very happy that was an accurate reflection of the benefits they were getting from lime. So it's a huge return on investment, where you're embarking on a nitrogen or a liming program. I suppose the nitrogen one is important because even where you achieve a pH of 6.3 to 6.5, you're then going to benefit from really good biological activity in the soil and the release of about 80 kilos of nitrogen per hectare per annum, which I call free nitrogen effectively. It's released from the soil, and that's 60 units per acre, which is locked up in the soil, and because you have ideal conditions, it then becomes available for grass growth. So each year that you maintain your pH at the 6.3 to 6.5, you're getting the benefit of that extra, we'll call it free nitrogen, of 80 kilos per hectare. And that's one that really feeds into big return on investment going forward, because it means you have better spring growth, and it particularly better response to the fertilizers you're using, particularly your P's and K's. It's really a whole package in terms of, as I say, the entire farm really working a lot better than it did previously in terms of grass production.
I think we've gotten a great picture, Ger, of what's happening and an action plan for our farms. I think I suppose the first thing is, if you have soil fertility results, it's definitely time to root them out and have a look. And in terms of if you haven't soil fertility results, that is something that farmers should look at immediately. And those colour-coded maps are, I suppose, very visual in terms of the areas of the farm that need action, and farmer advisors are readily available to help farmers with that.
Yeah, absolutely. I mean, it's a program that you're going to make great progress in, a liming program, and pH correction once you set on it. And certainly in the monitor program experience with us here in Kerry, we've seen them getting up to 80% of their paddocks correct for pH after 4 years. And it's really just a few paddocks that have come in lease ground or something that are not at optimum. So it's an easily corrected issue. So it's great to see the colour-coded maps changing from the really pale white colours right up to the deep green. You know then that's a farm that's firing in all cylinders.
That's great. Thank you, Ger.
Thanks, Emma-Louise.
And that's it for this week's episode of the Dairy Edge podcast. And my thanks to Ger Courtney for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify. And for more information, go to the Teagasc website at teagasc.ie. I'm Emma-Louise Coffey, and join me next time for your Dairy Edge.